Hi everybody. So I'll introduce a little bit about me. So I'm working as a consultant at Capgemini. So in our company, what we are doing, like we are extensively working with Docker and Kubernetes. So how many of you are comfortable with Kubernetes? How many are using in production? No. Okay, cool. So I'm also a part of Debian community. I'm like maintaining packaging for Debian. So here also we have community for Debian packaging. And I'm also a part of OpenEbs community for this contribution as well as like extensive user also for in our product also we are using. And we have set up one Kubernetes meetup in Chennai. So actually we are trying to build up a culture like every meetup is like just give a talk and just demo. But why can't we bring up a culture like contributing back to upstream itself? Like if you want to, yeah, if you want to like, you have some thoughts like, and if you find some bugs or something in that project, so why can't we like resolve that issue? And why can't we improve that project itself? So feel free to like come to that Kubernetes Chennai meetup. So we will club with this Docker meetup and make like extensively more contributing to like Kubernetes, and we'll like at the time, right? Everyone is saying that I'm not aware of Kubernetes, but in next meetup, like after like Kubernetes meetup we complete that, everyone should be aware about what is happening, how we can use in production, how you can bring up with more ideas, how we can contribute to like Kubernetes. So that's culture we need to develop in Chennai. Cool. So today, as Uma discussed a lot of things about like OpenBS, like how it's using, but still people are curious about like how we can implement in our production, how we can implement in our premise, right? So today I'm gonna show you about demo how we can use with Docker and how we can implement in our production. So it's like stateless and stateful application, like Uma told a lot of things about things. See, we have one like many application, right? So we have like loosely coupled different application like microservice, but that microservice like still need storage. Like we need to like permanently storage, and we need to store, and we need to like fetch back after later time, right? So this is what OpenEBS is coming to picture. Suma told a lot of things about how OpenEBS, how data is storing. So we can persistently store like whatever our application need in future, we can like permanently storage in using OpenEbs Jiva. So today I'm gonna show you about how we can like, I pull up one application like Bitbucket. So I'm going to show you a demo about like Bitbucket is there. Bitbucket is doing some data in like, I'm taking one infrastructure as AWS. So I'm trying to create two AWS instance. So I installed Docker about it, and I'm showing you how to like create one Docker containers for this Jiva. So it's having Bitbucket is there. So I will make one Bitbucket container and Jiva frontend. Jiva is one like OpenEBS one. We can containerize the storage. It's like iSCSI is using. So how many of you knows iSCSI? Okay, cool. So I will give you a brief introduction about iSCSI. See, at the end of the day, this Bitbucket need to store the data, right? Okay. So here in iSCSI time, like if you take about like SCSI, like a computer need to access the storage, right? His disk. So certain type of like communication is happening between our computer and storage, right? Like hard disk. So iSCSI is like your disk is not directly attached to your device. It's somewhere. It's like in some server, like we call SAN, right? So all this communication try to access to this through network. That is what I came into picture. So like front end application, like if you have a server and if you deploy an application, if the application needs to access the storage, it's happening through network. So all the things which need to access the storage is happening through like network. That is what iSCSI come into picture. So here, in the case of iSCSI, it's like client side is there, server side is there, what we call right normal. So in iSCSI team, we call like initiator and target. So here our machine is there, machine is trying to access storage. So whatever the mission, like we need to install like client application to access the storage. So what we call that machine is called initiator. So initiator is like trying to access the storage. So in like server side, we call like in their part, we are trying to install a lot of packages like for iSCSI. If you want to make your node to like iSCSI server is nothing but like we are creating a lot of like different volumes, like actual hardware, like how this actual hard disk looks like. So we will make that machine as a target. That is what we call. So like here one machine is there, another instance is there. So in both machine, I will install Docker, and in one machine we will create one like initiator and target. So in target we will call like Jiva front end, and one more machine is that I call right here the data is storing. That is called we call replica in Jiva team. So I will show you a demo about all those things. Here, so I'm taking AWS as an infrastructure. Like I have created two instances. So like first instance is like one medium instance I'm taking and one micro instance I'm taking. So here what the idea is like in medium instance we need to like create one Jiva front end that we in iSCSI team we call target, and one more instance is there as a backend. This backend is where the data is storing everything. So here this front end, what this Jiva front end what is doing, here the Bitbucket application is trying to access the storage. So this Jiva front end will take all this iSCSI command to like access the storage. So it will like unpack. So that storage command all pass through this IP protocol, like IP, and it's unpack it and take all this iSCSI command. And if the Bitbucket is trying to access the storage, whether it will check with control command or trying to write or read the data. So this front end will pass if this application is trying to store any data. So this front end will pass and store the data in backend container. So we have multiple backend container for higher availability. Means like if something happened to backend container, you can create one more container like backend. So this is where like Jiva high availability is doing. So I will show you first. I will create a Jiva front end container. So it's like we can create backend like front end. We can create a separate server and two backends are there. we can create multiple backends, and in separate we can create backend containers, and there the data is storing. So if one node goes down, still the replica is there. We can this front end is serving or taking data from the another nodes. So front end, yes. So it's actually, if front end goes on, like let's say like extra DB cluster, like if you have an like database, still the database cluster is there, right? In database cluster, if one node's got, each node will be like different container, right? That is what cluster is forming. So each node has this Jiva front end and still backing all the data. So if any front end crashes, still the database cluster is managing, and database cluster is taking from another nodes. That is what, how this backend is working. Yes. So here is like in iSCSI term, target is there, right? Target is where accessing all this iSCSI command from initiator. So this target need to store the data somewhere, right? This target will unpack all this IP packet and take this control command and check whether it's read or write access. If it is read, still the backend is storing in replicas, right? All the data we are storing in replicas. So this front end will communicate with the replicas and take the data and serve to initiator.
I think we can have one-on-one later.
Yeah.
Guys, have you got your laptops with you? Are you like, when you do something new, play around with Dockers, just go to play-with-docker.com. You can spawn a new container, run it in production, you can have the ports exposed just within a single click. Try with it, if so. None of you guys have got laptops? Play-with-docker.com. You start a container to it. So I'll show you like deploying things within seconds we can get it done. You'll have a feel of how Docker containers and how you can have OpenEbs with it, a lot of stuff. Yeah, I'll show you.
I asked you not to do that.
Because there's a TV setup now.
Maybe we'll do my talk another day. Yes. We'll do my talk another day. Hold on. It's coming.
Sorry.
So even the video display has got disrupted. Or we can just go for a quick hack. Or you can just give a small demo about that.
No, you will need the screen, right?
Yeah, so you get that.
You can go for that.
Yeah, are you like close
Yeah.
for like how many minutes?
Like 15% audience.
Impossible.
So here Docker run command I'm giving, and here I'm giving network is equal to host. It's actually the ideas behind it, like we are creating like separate VLAN for the security part, like how this front end and back end need to be communicated. So it should be like separate command, like separate network. It should ensure the security while communicating with front end and back end. So and network latency also we can a little bit lower, like because directly we are communicating with host. And here the front end we are exposing 9501 port for communication, less like initiator what I told, initiator is communicating with target, a port is needed. So here 9501 all the control commands, like what is the status of initiator and how this replica is working fine or not, such kind of control command we can like it's a Rust API and we can use curl command to show the status. And 3260 is like ISCSI target port number which I am exposing. And I am pulling like open EBS Jiva image. And in Jiva image, we are launching like container. We are launching a target. So it's called controller. And this controller will like create one specific disk for that. So just in like initiator, we are trying to discover the target. We will get one name. So here we can give any name. And I'm giving like 10 GB. I need to like expose as a disk. It's actually like we are giving as a front end as a God GT. It's like Go framework for ISCSI protocol. So here this front end is using this framework. So I'm specifying that. And I'm giving that specific IP address. This I am giving. Here the front end as a controller is running on the same machine. So I am exposing that IP address as a front end. So here by using this IP address only, like initiator is discovering like disk is available or not. So container just we need to check. Now the container is running. So the control part is completed. Again, we need to create the replica. So we need to switch back to a next machine and we need to create a replica. Here like 9502 and 9504 like port is exposing. It's like 950 for the control commands to check whether the replica is still alive, or we can issue the lot of it's actually a Rust API. So we can curl it and check whether status. And 9403 it's actually like communication between like front end and back end to check this front end is communicating to back end replica using this port for data syncing. And 9504 is like if sudden, like if you need to add any extra replicas, or if any replicas come by, still need to sync with the old replicas, right? So this support is communicating. And 9700 to 9800, it's like syncing all, like between different replicas, right? If while transferring data, it can use different threads. For that only it's using. So before getting to that, like backend replicas need a storage, right? It's need to store the files in hard disk. So in before getting to that, we need to create one, like in file system in our like host. First we need to create a directory to store the data. So I'm creating one directory to store data, because replicas are storing data, right? So I'm creating one directory.
So we'll start with one session. It's a glimpse of like the next catch up. Okay.
Yeah, yeah, I'll finish quickly.
That's how we are. You're confident up here, yeah, you can have it. Meetups are also about, technical. Usually, people will come with laptop. Then they try to, they were doing something, they got stuck. Come to meetup, then you resolve it and go back. That's how we should transform the meetup. Right? There's always one introspect. Learn about it. Then, but obviously, wanting to meet some experts or fellow contributors, you can solve that problem. What we do, what we did in our last meetup in Bangalore is they asked whoever wants to run the entire OpenEbs, like come with laptop, we'll only run this. Their meetup was about 10 minutes intro. 2.5 to 3 hours was about installing some techniques. Then we also provided some exercise after. The whole idea is, we will get used to this Docker command, technical, but we are all technical. So we were just expecting around like 100 folks coordinated by around like 260 people. Honestly, we are not 200 people, but they are pretty good. We're expecting to see the next goal to around Meetup in Bangalore. So you can meet people, okay, you're not in Bangalore. So like missing the technical stuff, Bangalore, something, the energy, have like, okay, that's not happening in Chennai. We make it done. So, yeah, that's all. So feel free, man. Ask questions. Think twice. So we can have plan hang-out sessions someday with a full workshop thing. Take a snack group or anyone is up for the next topic for it. Making it down for the replication layer. The front-end server is the replication of the back-end server. Probably you may need like a big software object connect to our existing application. Then there will be two or more copies. Like just repeating the story, right? So you copy one copy three and all. So the only thing here is not monolithic. Volume will have monolith. Volume will have one and software that is taking up one. Not with the targets. No, the targets. If you are still up with targets, target will have
I can just find up one second. So here see, I'll wind up one more thing. Like we have one two servers are there. In one server we have created one front end, and another server we have created one replicas. And in replicas we are storing all those data. And once the two containers are up, so we use in Ubuntu, all we have iSCSI ADM is client is there. We can use that iSCSI ADM commands to discover the target, whether that volume is available or not to use in our disk. So here I have given one command iSCSI ADM minus discovery minus T is like send target, and minus P is like IP address of the controller where the controller container is running. So once we discover that one, we will get as like saying that target is found. Here you can see that IQN, like the name which we have given in Jiva, it's discovering. So now the iSCSI is discovering. So once we discover this iSCSI, again our like administration part is like we need to attach this SCSI storage to your host and format that storage with ext4 file system, whatever file system you need, and then you need to mount that storage to your disk. And once you mount that, it's like normal disk, like. And so if your application need any like volume, so still docker minus v command is like volume. You can create like attach like directory is there. You can attach like directory to like from the application you need. And once the application come, you can start writing all those data. Whenever if like if your application like crashed, again if you can create same kind of application by using the same storage, still the data will be available. So this is what Jiva is doing. So folks, like you can contribute to a community and you can hang out, and we'll be aware in the chat. The Slack channel is there. You can come and ask questions if you have. And if you have any live demo, you can ping us. We will give you personally also. Okay, thank you very much.
Rahul, thank you. Guys, we'll proceed. Mohan, so give you a glimpse of, yeah, not the whole talk.
Hey guys. Hey guys, thank you for actually waiting for my talk.
Hello.
Oh, this actually works. This works fine. Oops. So, my name is Mohan. I'm going to talk about how containers work internally. So it's like a continuation of what we discussed last time. Since we're like short of time, I will give you a general glimpse. We'll be doing the same talk next meetup, so don't worry. We have another Docker executive coming in 2 weeks or 3 weeks. So, as many of you might actually know, if you are tracking the Docker world, you might have heard about the Moby project. Even if you didn't, like all three speakers since the morning use this word in one way or the other. So the reason is, in this commit message, like it's not a commit message, it's comments on issues. Solomon Hykes actually described like a bunch of reasons. Most of it boils down to like Docker project became too big to maintain in a single repository, and they had to like spin off different components so that like different foundations can handle it. Like how they extracted container D and gave it to CNCF, and how they extracted run C and gave it to OCI, and like so they have this different parts of the Docker, the whole Docker thing, maintained by different people. So they needed a place where they can integrate stuff. Think of it like Ubuntu, right? Ubuntu is not Ubuntu if you don't have LibreOffice and Firefox. It's part of Ubuntu. But Ubuntu people don't do LibreOffice and Firefox, right? It's made by somebody else. And you need a repository to like bring specific versions of Firefox and bundle it together to make like Ubuntu 16.04 or Ubuntu 16.10. Look, how many of you are like Linux users? Like use Linux one way or the other, right? Android doesn't count. So you should know, right? The open source, when the project like crosses a certain limit, certain size, it becomes a nightmare to maintain it. Especially when you have people of different companies contributing to it and they all have a political agenda. And also the reason is, a lot of companies have started using the Docker brand, not just companies, like even other open source projects. Like what is Kubernetes? Kubernetes is an orchestrator for Docker containers. That's how it started, right? So the Docker Inc. didn't feel like it would let other people use its brand. So they wanted to like restrict people from using their brand. So if you start a company like what Mr. Uma Shankar is doing, he can no longer call it a Docker-based solution without getting into legal trouble with Docker Inc. He'll have to call it a Moby-based solution, even though his product is actually working with the actual Docker and not Docker components, right? So now Docker is now an actual trademark. So that's kind of half of the reason why this is, and the rest of the reason is about maintenance and the general complexity that it has become. So, but this whole message has one word that kind of intrigued me. It's this word called modular. We all like modular, right? We're all Linux people. We like modular stuff where you can swap things out and replace it with other things. So Solomon Hykes, the Docker guy, he promised people that he'll make Docker more modular. So, but Docker is kind of already way more modular than like you would expect, and that's a good thing, right? So I wanted to like see how deep we can go, like how many different components and how many different layers of abstraction we have in the form of Docker, and where the actual Docker magic is. So before, like, how many of you are new to Docker again? Now the crowd has changed. How many of you are like complete beginners? So I don't have to like. Okay, do you want me to show how to use Docker, or do you know that already? Okay, probably not. So what Docker does is you can do like Docker run an image name and a command like bash, and it will create an isolated environment where even if you do RMRF, nothing will happen. Nothing will happen to your host machine. It's like inside a virtual machine, right? You can achieve process isolation without using any hypervisor like VMware. That's what Docker does. So how does it actually do it? So when I did the Docker survey, Docker Chennai survey, I found that a fair majority of you were using Docker for Windows. So we better start with Docker for Windows if we want to like dissect into what Docker is. So if you're running Docker on Windows, how many of you are like on Windows using Docker? Very few, okay. So if you're on Windows, what you would do is, what it actually does is it creates a VM called Mobile Linux VM. And inside that VM, you have the actual Docker binary. And it communicates through a port on your Windows machine, through like all these commands. Docker has something called a remote API. So when you enter your command on Windows shell, the PowerShell, it goes through a port to the Docker remote API running inside your Linux VM, and the command executes inside your Linux VM, actually. So what you have the Linux VM and you have the Docker binary inside, right? So what does that have? Docker binary has two things. One is the actual CLI, and then you have Docker Swarm. Swarm is naturally not what is doing the magic, right? Swarm is just orchestration like Kubernetes. So that's not what is doing the magic. The magic must be in the Docker minus Swarm part. So what that does is the Docker CLI communicates to a component called containerd. Containerd is something like when Docker first came out, it was a monolith in itself. That's pretty ironic, but Docker was a monolith. This meant that you needed root permissions to actually run containers, which is actually bad, right? So they spun out this thing called containerd, and not just that. Also, you have projects like Kubernetes using Docker, even though they don't actually need the whole Docker thing, right? So they spun out this thing called containerd, and they even donated it to CNCF, which is a Linux Foundation affiliated entity. And so, so they have this Docker CLI that talks to containerd, and the containerd is actually responsible for doing all the operations, literally, from getting the images to decompressing the images to actually mounting the file systems and running your process. Everything containerd does it. Docker CLI is just a wrapper around containerd that gives you like nice commands like run and create and all that. So this is the diagram that I got from containerd.io site. What it does is it takes the commands from you and it unwraps stuff into root file system and config.json, and it sends it to some component called runc. So the magic must exist in runc, right? So what is runc? Runc is another wrapper around lib container that takes two things. One is a config file in the form of config.json, and then a rootfs. So this is actually responsible for running the containers. Whatever you give it, this is actually responsible for doing that. I can actually show you a small demo, but since we are out of time, I better skip the demo. But the magic, you don't see the magic, right? So we actually need to go deeper. What are the actual primitives that we get from the Linux kernel, right? Only C groups and namespaces are the actual primitives with which you compose containers. So nobody cares about C groups actually, and namespaces are the real deal. C groups are something like when you get to specify how much RAM and how much CPU and all that a specific process can use, and that's all there is. So the actual magic must be in namespaces, right? So there is this small Go code that I need to show. So this is like a simple Go program, less than 50 lines, probably more than 50, but around that. So what it does is it creates a container, and when you run it, when you run this program, it calls itself, and when it calls it the second time, it creates a container and puts itself into it, right? So here's the thing: when I execute this, okay, so when I do sudo mohan container host, it gives you the PID in the host, the process ID in the host, and the working directory, which is this. But when I do mohan container /container, see, the process ID is now 1. Because the process ID, as you all know, it must be like the init process, right? Like, oh, so that's PID 0, I guess. Never mind. So, this means that this is like the first process that's running inside the container. Like, so this means that it's in a separate process namespace. So this is actually all that Docker is doing. It also does something called let's say a network namespace, but that's kind of hard to demo. So let's just stick to these two things. One is a process ID, and the second line demonstrates you that these two things are in a different file system. Actually, Docker actually uses something called mount namespaces. But since I couldn't actually get that to work, I used good old chroot. Contrary to popular belief, Docker actually doesn't use chroot internally. It uses something called mount namespaces. So that's all there is. But where is the magic, right? Where is the magic? That's the question. Like, these are like what 4 lines of code. How did Docker become a huge movement from just these like 4 or like less than 5 lines of code? Like, we have about 7 namespaces. Is Docker all that is? Not actually, because when Docker first came out, it kind of like promoted a specific set of practices, like immutable infrastructure, microservices, and having like shipping your entire machine, which is literally immutable infrastructure. So it kind of like promoted a certain set of practices that made the developer's life easier. So it was mostly about the developer experience that promoted Docker rather than the actual technology. So that's where the magic is. It's about it's about thinking from the perspective of the user of your product rather than like increasing the efficiency of your technology or something like that. So that would be it. Thank you.
So I'll show you one thing. So I was like sitting last night. I just came across this. So have you guys like tried this with this Docker? Anyone of you guys? Okay. So I'll show you how it happens. VM onto which you can display with multiple containers. So I'll show you like how you can play. If you think installing Docker and getting the whole framework, point is like installing it and then setting up the whole repos, the repositories and also. Yeah, so I'll show you one thing. So I am inside a node now. I'm using a service called console. So this is a service discovery, a package, a binary for it from HashiCorp. It's called console, CONSUL. So I'll just show you how to run it like in a single go. So I just got Docker. We are using the node first. So I'll start a new instance. So the keyboard reset and what image I'm using. You can just go online, go to GitHub. So it is an open source project if you would like to check. And yeah, as it says, it's in a highly sandbox environment, not to use any of the keys. And Docker is like already pre-installed, so I'll just do a Docker run minor actually, then I'll just like configure, open the port, and then again. So yeah. The whole screen is not coming. Yeah, so my service is running. So there's a column that has already happened and it is exposed on 8500. So I just click here. Now the service is exposed. Within like 2 seconds, you can just play with it, have a new service, and specifically, I got to know so a lot of people like double one start like hanging up with this, and a lot of people actually like wrote middle players over this open source library. You can just like go to GitHub, go Git, look into the post, and yeah, a single code you can run like make POCs out of it. You can run like blockchain apps over it. So within seconds. So I just showed you how the deployment will happen. So anything that you want to test. So at times also like when you've installed Docker, at times the configuration goes like somewhere in vain. You're not able to even see what's happening, what's not. So it's a sandbox, a small sandbox. You can even like I can run this in a screen also. One more thread. But yeah. So if I go, I'll even show you something. I need to proceed. I click on. So it's even showing me the whole output, and I can even see like the logs directly to AWS from a demo machine even. That could be even done. So a lot of like I can just have some keys, some hashed keys that I can send, and over a secret if I have on my other AWS or any package service that you are using, you can have. So and one more thing to what I had a proper demo for it. So how many guys of you guys are actually like familiar with Jenkins, CI/CD pipeline? Just to know it. So how do you like deploy Jenkins? What do you think? Is it a pain? And if you've got like 100 projects, 100 pulls and 100 pushes every time, there has to be a pipeline that has to get passed through. How do you like go through that pain point? So do you get like big machines for? Do you like plan for that? Some insights if you can just throw. Okay. Okay. What about like the machine sizes that you plan for? Yeah. Okay. That night when it is of no use, still you're paying the rent for it. So yeah, we can optimize the storage even. I would say so. Whenever there's a task needed on it, you run it and then kill it. That's the beauty of containers altogether. So what I did was, so I have a working demo, but then that will take time for me to like go through. So what I could do is, task that I made yesterday. So what it is building, yeah. So does is Jenkins. So whenever you want to like have a worker with Jenkins, so it spawns a new slave. So right now, what I've seen people is like they'll have a big machine and run those slaves over the same machine. But just imagine if you have got like a, if you want to have do some testing over like a Windows image, how do you do that? So you've got a Docker plugin for it, but then eventually if you've got like around 100 containers, 100 different images to test upon, to like go through the pipeline, how do you plan to do that? Probably it would be a very big machine, and things will again get sequentially queued up. To resolve these things, what I did was I configured it with ECS. So whenever it will spawn so ECS is Elastic Container Services through AWS. So onto which, so it is I would not say a sandbox environment, but yeah, I can run containers, and that service, the Docker engine, is managed by AWS, and we are a proper AWS shop as Freshdesk. So containers are cheap, and it is isolated from the other container. And since we are a polyglot company, I would say multiple languages altogether, multiple platforms. So how do you think we could do? Any suggestions over it? Guys, share up. You need to even give some suggestions over it. Even. So what do you plan? So we have multiple services, multiple stacks. How can I do that thing on the screen? Orchestrate them. What do you think? So Kubernetes is overkill. Because if I want to just go for an integration testing or unit testing, why should I even use the kubectl? It will have a very big like orchestration framework. There will be a cron tab running properly. So it's too many things to run. So I can even like make it much more optimized. Then even in machine, I've got like 100 pools. We have got around like 500 developers. Then how does it happen in a day? And there's no one at night. What happens for the machine? So a solution is you can have nodes. So whenever needed, it will spawn a Jenkins slave over ECS. So that will be a randomly created slave, but I'll specify which image to use and what commands to execute in the entry point.sh. That is when you have few commands to run and override the Docker container from just the Docker run. So it saves our cost, and I can scale up to like tons of containers, meaning I can have like 1,000 polls in a single second and still just pay for the number of polls or the number of builds that I'm going for. And in that, I can even do a lot of testing, even like UI testing or like testing on Windows images or Linux images, anything. I can just play with it all together. And the beauty of it is after my task is done, I can just close it seamlessly. I don't even need to think twice about, okay, if my container or my machine is up or down. So this saves my cost a lot. So yeah, probably you guys are even from the microservices background. So yeah, it does save a lot of cost. This is one hack that I did. So there are plugins available for that, but yeah, there are scripts which we wrote over it so to make it work. This is not yet prod ready. So this was just a POC that I just did last night. But if you want to even have a look on the code and all, so I'll share you with the Git repo how you can configure it, because the open sourcing have not mentioned much of a documentation. So I even encourage you guys to like contribute open source, man. Why not do that? And you guys are all from container background. Why not? Yes, because a smile would not do everything. The fingers has to like type, and properly you have to like contribute back to the open source community too. So yeah, this saves us like around like 30 to 40% cost of the slave machines that we used to run back then. And it's a big cost, I would say, because being an AWS shop, we used to pay millions at times. So yeah. Yep. Any questions? Yeah. Yeah, console, yeah. No, it's not my own service. So it's a service. I'll tell you what it is about. So it's a service by HashiCorp. What it does, just a small discovery management service. So if you've got like n number of nodes in a cluster, and if there's a new node coming up, so how do you like make that node attached to that cluster? Right now, what happens is you have to like manually mention the IPs of the new node coming up to the cluster. Here it has got, so it is empowered by the consensus algorithm, which graph. And yeah, so the new node, when it comes up, the network itself discovers when there's a if this node has to be connected to this cluster or the other cluster, so that it's like purely distributed computing. And you can have a data critical job in that because it's real time. Like how blockchain apps are right now running is they have an eventual consistency. That means like if you even run a Redis cluster and take some time, so we can even like this on a console. And I was just looking into just a quick hack, nothing like for a demo purpose or yeah. Jenkins thing, yeah, I was just thinking about if we could like even containerize Jenkins. So right now it's running on a host. I can even run the same on a container itself. So whenever needed, because I'll have a persistent storage attached at my AWS end. So whenever needed, I can close the Jenkins, I can upgrade it without even thinking if my data will be lost or not. And containers are like pretty lightweight. So yeah, that's about it. Not yet planned to use OpenEbs. I have to explore it even. Yeah, but yeah, into Docker, couple of things. So you can just go ahead and play with this thing. So you can even form a swarm cluster, I would say. I'll show you like even Jenkins, how easy is it to set up. Docker run. And 4 gigs of RAM is like decent enough to like just play around with it. Feel free to have questions, man. Yeah. Okay. 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 Yeah, why not? So you can even have a Windows app running on this, man. So people even, so I was just going through some random video on Reddit. So some link I followed. So one guy, what he was doing was, he was running this Internet Explorer on image, instance of an image container, a container of that Windows Explorer image over this machine. That's how I got to know. So he was doing some Selenium testing, yeah, and he wanted to do that on an IE browser. So yeah, I'll show you. See, let's see if Jenkins is running or not. Yep, we're up. Single go, and I've got this password, and yeah, I just put it here, and we're up here running live. So that's how easy it is with containers. So just play around here. In terms of okay. Still, yes, why not? So it is beneficial in terms of that even because see, right, still you will be having some CP large or some machine, some big machine. Yeah, so so you can have a Jenkins running on just a 512 MB RAM. Yeah. So it's all about like distributing things all together rather than like having a single machine. So my plan, so I love distributed computing. So in terms of that, yes, why you can have like multiple clusters all around. Even if it is a 5 servicing, it could be a data intensive job or not. So that's again depends upon the use case that you have. But yes, I've been seeing a lot. So I just had a thought about. A lot of people would have for sure about the same, but then yes, this is what I found out. Yeah, for me, and probably it could be useful for you guys too. I just wanted to share about a lot of like I have got a deep dive onto how it happened, what are the internals, but probably we'll stick for that in the next meetup, I suppose. No, so I cannot disclose that. Yeah. So a couple of things. Yes, those are all into IPs. No, so again, on-premising, this is not what we think of going forward. Cloud is the next thing. What we look into, we are, but on-prem thing. Uh, we have not looked into that as of now. We could think of that, but yeah, as of now, so I'm not the right person to like comment upon that. So that has to be taken call by the VPs. Yeah, probably yes. So a lot of things. So you can just go on this website and even like, if you want to just ping me, so I'll just share you my email address. Just ping me whenever. So even if you have any doubts. So yeah, but yeah, you guys should again show up for the next meetup though. That's how it should be. And you find me Akhilesh Arora almost not doing the business. Yeah. Cool. Any questions? So a lot of cool things can be played with Docker. So even like you can have a layer between the hypervisor and the container that you're running. Go for that. So a lot of like changes could be done. Images and specifically when it comes to like QA and all, a lot of right now what people I've seen a lot of time it passes through a lot of pipelines. So how can we like sandbox that environment with multiple configs, multiple builds? So then again, Docker helps a lot because the storage can be anywhere, but the environment that I need, I can run it simultaneously on multiple builds with different configs altogether. So this gives me even the performance ratio where the multiple images that I'm running, the technical config that I change up, I was playing with. Yep. And this like understand. We optimized a couple of machines that we had by more than the CPU usage used to be like 30%. We optimized like around like 15-20%. So yeah, that's how. Yeah. Anything else, guys? Or shall we like ramp up, close it off? Okay. So we can proceed for lunch. Network with these guys, Harisha.